Okay, let's just say we want to find the area of a triangle, but it's a non-right angled triangle. Let's just say that that's 10 and that's 20, and we know that that's 30. Area equals a half base times height. So we've got our 20 as our base, but we need our perpendicular height. So we would go, would we not, sine 30 equals O, which is my height, over my hypotenuse, which is 10. So H equals 10 sine 30, which is 5. So we would just go a half times 20 times 5, which is 50. Area is 50. Basic Year 9 trigonometry. I'm going to do the same thing. Non-right angle triangle. Let's go, I don't know the side length, and I don't know the side length, and I don't know my angle. Area equals a half base times height. A half, the base is A, and we need to find this perpendicular height. And you go, oh my gosh, back in grade 9 I could do that. So you would go sine theta equals opposite, which is your perpendicular height, over hypotenuse, which is this B, just like we did before. And we would get our perpendicular height would be equal to B sine theta. This perpendicular height is this thing here. So we end up with the sine rule for area. Area equals a half AB sine theta, not rocket science. Let's use it. Calculate the area. State the rule. Oh, look, I don't think I can even be bothered doing that. Surely you can put that in your calculator. Textbooks are really good at giving you practice, so can you see that the total area here is just two different triangles, two different calculations, and add them together? Let's just insert working. You can do that, just go for it. This was hilarious. This is in this chapter. I don't know what they're thinking. Even that's a right angle triangle, rectangle and a triangle, but goodness, is that not just a trapezium? So you're going to use the area for trapezium is A plus B on 2 times H. I don't even know why that's in this chapter, but it is. This is a bit more like it, good old textbooks. A triangle is 2 sides, 9.5 and 13.5, and one angle of 40.2. So you can see here how I can have the 40.2 in there, or I can have the 40.2 in there, or the 40.2 in there. And clearly they're different triangles, and because you've got this angle and the side opposite, you have the sine rule, so you can work out all the other unknowns and then just plug it into your area sine rule. Again, volume practice, the textbook's excellent at that. What the textbook didn't do was give you the question that you really need to be asked was, let's just make these round figures. Let's make that 12 and that 14. Let's just say that the area is equal to 42. The area is 42. Find theta. So A equals a half AB 42. I reckon this would be a tech-free question. Because you might not have noticed, but I haven't just made these numbers up on the spot. We're going to end up with sine theta equals a half. So theta would be 30 degrees because you're going to have an exact value triangle. Excellent. We love trig. Get to work.